So a little bit about how we read atomic notation. So atomic notation is one way that we quickly represent everything that's here in terms of information about atoms. Their element, their mass, and their atomic number. So as you can see, this is the standard form. We have the atomic symbol, the element symbol, so like this is hydrogen. And this particular isotope of hydrogen, this version of hydrogen, which has a proton and a neutron, what we call deuterium. Not every isotope of every element has a special name, but hydrogens do. There are three types: protium, which is what most of the hydrogen is, just one proton; deuterium, which has a proton and a neutron; and tritium, very rare form. You only find it usually where there's been nuclear reactions and neutrons have gotten absorbed into the nucleus, which would be two neutrons and a proton. So here's the symbol notation for deuterium. Mass of 2, atomic number of 1. So the Z, remember, Z is shorthand for atomic number. It defines this as hydrogen. So from this information, I know there's one proton. I also know, because of the difference between these two numbers, that there's one neutron, because protons and neutrons just about equally contribute to the mass of an atom. Because this particular element has no charge, it's neither positive nor negative, then if there's one proton, there also has to be one electron. Protons and electrons are equal in a neutral atom. Not every atom, however, is neutral. Some atoms, as we'll learn when we talk about bonding, become more stable by either gaining or losing electrons. And when we have an atom that's charged, we call that an ion. And specifically, if it has a positive charge, we call it a cation. Think of the T like a plus sign if you need some way to remember that. Or if you like cats and you feel positive about them. But if you don't like cats, the T is like a plus. Okay? Cations are the positive ones. Anions are negative. So it's not cation and anion. It's cation and anion. Much like, if you're familiar with electric wiring, you have the cathode and the anode. They correspond. Okay? So if we look at this, take an example of sodium. And sodium, in its preferred way of being, will end up losing one of its electrons. So if I take the information here, it has 11 protons. All right, and the P with a plus is just a shorthand way of indicating protons. N with the 0 indicating no charge is the neutron. So 23 minus 11, 12, right? 21, 22, 23. Yep. Now, this has a positive charge, meaning that it has one more proton, because electrons are negative. So if it's positive, it's given away. Electron giving is good. So it only has 10 electrons. Okay, so if the sign is positive, you reduce the number of electrons from the proton number by whatever the size of the positive charge. On the other side of the coin, with our anion, here's chlorine. An isotope of chlorine that has a mass of 35. If it's chlorine, it has an atomic number of 17, so 17 protons. 35 minus 17, there are 18 neutrons. This has a negative charge. Electrons are negative. If it takes in an electron, which is what this atom does to be more happy, in a general sense of things, especially if it gets together with something like sodium to make table salt, then that means it has one more electron than protons. So it has 18. So from reading the notation, you always have the atomic number, which tells you the number of protons. If there's no charge, then you also immediately know the number of electrons. If it does have a charge, well, then you have to say positive means less electrons, negative means more electrons. And then, to figure out the number of neutrons, it's the difference between the mass number and the atomic number.